Hey, it's Mr. Celtano, and this video is going to be part one of our series about the theory of the atom and the scientists that came up with it. We're going to go through a little bit of the story of the past of how we got to this point, so I do recommend getting popcorn and kind of sitting back and relaxing as we go through this history. So to start off, scientists have always wondered the structure of matter and how it behaves, right? I mean, we've been working on this for a long time now, and for centuries, man asked themselves this question. And the most important thing is that even today, we're still figuring out things about the atom. We don't know everything. We can't presume that we know everything. And so we've known a lot now, but we're still trying to figure out a lot more about the atom. So we're going to go into scientists who knew a little bit, and then as we go forward, we learn more and more about the atom. So here's just an idea of all the things we're going to be covering, all the way from the beginning to all the way toward more modern thinking of the atom. So it took a lot of people to get to the idea of the atom we know today. We take it for granted that we learn it in school, but it took a lot of different scientists who made different contributions as to what made the atom. And so we're going to learn all about who did what to help discover exactly what is in the atom and what the atom is made up of. So we begin our story with the ancient Greeks. And so the thing about the ancient Greeks is that they were philosophers, right? And so what that means is that they actually had no scientific method. They didn't test their ideas. A lot of them sat around and just thought about things very in depth, right? I mean, they came up with some great ideas, but they never tested any of it. And so one of those first philosophers who we focus on, who really had the first idea that we talk about, is a guy named Democritus. And so he was way back in 460 BC is when he was starting. And his basic thought was that the world was made up of two different things, right? You either had matter or you had empty space, which makes sense, right? I mean, there's either nothing there or something there. The other thing he said, though, is that the matter, if you broke it down small enough, so if you took matter and divided it in half enough times, eventually you would stop at an indestructible particle. And that indestructible particle he called atomos, which meant indestructible in Greek, which actually sounds an awful lot like the word atom, right? And so this is where we kind of start everything. So if you look at our image over here, here's an idea of what Democritus thought. So you keep splitting matter until eventually you stop at the atom. So that was Democritus' contribution. Then enter Aristotle, right? So him we've heard of before. And he actually believed the opposite of Democritus. He thought that matter could always be divided in half forever. You could just keep chopping and chopping and chopping infinitely. And so because it could be continuously divided, we called that the continuous theory. And so that's what he thought. He also thought, and this is kind of interesting, that all matter was made of four basic elements. So can you guess back then, like what they would have thought were the four basic elements? So if you guessed earth, fire, wind, and water, then you were correct. What does this kind of remind you of? A little bit like Avatar, right? So that's what they thought back then. That this is what Aristotle was preaching anyway. So, and this kind of makes sense if you think about it. Like, for example, if matter was hot, maybe it was part fire and part air, right? If it was dry, maybe it was made of earth and fire. So, for example, rabbits are warm, so maybe they had fire in them, and then they're soft, maybe there's a little bit of air. They're water for their blood and earth to make up the body. It's not true, but it's what they thought of back then, right? But the most important thing about this is that they didn't use any scientific method, right? Just like we think of today, what's my hypothesis? Let me test it. They didn't test it at all. There were no experiments done on these ideas. They were just ideas. And even if they wanted to experiment, I mean, how could they, right? I mean, this was ancient Greece. They didn't have the materials required to do that, for some of them. So who do you think actually was the one they went with? Do you think they went with the atom, the atomos theory? Or do you think they went with Aristotle's theory? So the answer, actually, surprisingly, is that they went with Aristotle's idea, which we know now is, like, not true, right? And this idea of Aristotle went all the way up until the 17th century. So we're talking about way back from almost around ancient Greek time to the 17th century, right? The 1600s. They thought this until then. And the reason was because Aristotle had a lot of clout. He was the teacher of Alexander the Great. He was a pretty famous guy, and so they thought, well, he must be right. So that's where we kind of pick up again in the 17th century. And then at this point, people are starting to form, like for example, this professor named, the scientist named Antoine Lavoisier started to form more of the modern thinking of what we're thinking today. And Lavoisier basically said, and this is in the 1700s, he basically said, well, he noticed that in a chemical reaction, the mass is not created or destroyed during a reaction. So you have the same mass that you started with the reaction and the same mass at the end of the reaction. Can you remember what this is called? This sounds awfully familiar, right? So this is actually called the law of conservation of mass. So that was Antoine Lavoisier who thought of that, and it was in the 1700s when it happened. So now we're getting closer to real thinking here on what exactly makes the atom and about chemistry. Another important scientist that we want to know is a guy named Joseph Proust. And so, like Lavoisier, he was a famous French chemist. And when he looked at water, for example, he found that it was always 11% hydrogen and it was always 89% oxygen, no matter where he got the water from. And so he noticed that all the matter he looked at was made of very specific proportions. And so the way that I remember this guy is Proust's proportions. All matter is made of very specific proportions. You can't just take random pieces and put them together in any order and hope it works. And this makes logical sense. Like, for example, water is H2O, right? It has to be H2O or it's going to be a different chemical. So it's 2 parts H and 1 part O, right? H3O is certainly not water, and H2O2 is definitely not water, right? So these are different proportions. So water, H2O. H2O2 is actually peroxide, which is way different, right? So you can thank Proust for first discovering this idea that matter must exist in specific proportions. So Proust's proportions, that's how you remember. Okay, but now we go back to specifically the atom, and now we are going on to a guy named John Dalton. So Dalton's very famous. He was an English school teacher and a chemist, and he was looking at the experiments done by Proust and Lavoisier and some other scientists, and he came up with his own atomic theory, right? So at this point, in his lifetime, this is our best we have for what atomic theory is. And so he took that idea from Democritus that all matter is made of atoms. So he agreed with that. And he also felt like Democritus that these atoms were indivisible, right? They were indestructible. They couldn't be divided into smaller pieces, right? So you have this atom that makes up something, and that's the building blocks of everything, right? And we kind of agree with that today. He also said that, according to his atomic theory, that atoms of the same element are identical. So one atom of copper would be exactly the same as another atom of copper, right? Because those both make up copper. But he also said that those atoms are different from other materials, so copper atoms would not be the same as gold atoms, which makes sense. And then he also said, for the fourth part of his atomic theory, that atoms of one element can never be changed into atoms of another element as a result of a chemical reaction. So the atoms are just rearranged in a chemical reaction, right? That's a lot like what Lavoisier said with the conservation of mass. So he said the atoms cannot be changed into something else. They only existed as atoms of those material, and they got rearranged into different chemicals. Okay, now and then this is a lot closer to what we know today, right? But there are a couple things that make it a little bit off now that we know a lot more about this. So he wasn't entirely right? So what is the difference between Dalton's theory and what we know now? Well, for one, we know the atom is not indestructible. Because you have to realize that Democritus and Dalton, these scientists thought that the atom was a lot like a pool ball, like an 8-ball, right? And so it was like this hard thing that couldn't be broken down into anything smaller. We now know that there are things called subatomic particles, right? So the word sub means beneath, and atomic means atom, right? So there are actually particles beneath the level of the atom that make up the atom. So what are those particles? What actually makes up an atom? I'll give you a hint. There are 3 that you learned in bio that we're going to be covering again this year. So think about that. What are the 3 particles that make up an atom? So the answer is protons, electrons, and neutrons, right? So we now know that actually the atom is not indestructible and that there are pieces beneath the level of the atom, pieces that are smaller than the atom. Okay, there's also something else. So remember that Dalton also said that atoms of the same substance were all exactly the same. Now we know that that's not really true either, because of this thing called an isotope. So for example, there's a hydrogen with no neutrons, and then there's a hydrogen with 2 neutrons, or there's a hydrogen with 1 neutron. So actually the atoms are not exactly the same. They each can be different. Most of them will be the same, but there are some isotopes. And again, the thing that makes it an isotope is just that it has a different number of neutrons. So we'll be going into that more in the future, but you just want to know for now that Dalton was wrong, because there are things that are smaller than the atom called subatomic particles, like the proton, the electron, the neutron. And you also want to know that there are isotopes. So not every atom is exactly the same. You could have a hydrogen atom that has no neutrons, and then you could have a hydrogen atom that has 1 neutron. That makes it a different atom, even though it behaves exactly the same way almost. It just is a little bit heavier. So that does it with our first part of atomic theory. So you really want to make sure that at this point you have down Democritus, Aristotle, Proust, Lavoisier, and Dalton. So those are the scientists that you want to make sure you know at this point. And remember that up to Dalton, they really thought the atom was like an 8-ball, that it was like this solid, indestructible mass. And we'll find out more about that soon.